Very warm good morning to you all. I'm Duvuri Subramaniam. I'm an assistant professor of aerospace engineering here at the Indian Institute of Science. We are all gathered here for a very special occasion to celebrate the life and legacy of an extraordinary human being, Professor Roddam Narasimha. So to this event, I'd like to begin by welcoming our chief guest, Sri Somnath, Secretary, Department of Space and Chairman ISRO. Thank you, Sri Somnath, for accepting our invitation and being here despite your busy schedule with the GSLV launch tomorrow. I'd also like to welcome Dr. Samir Kamath, Secretary, Department of Defense, R&D, and Chairman, DRDO. Thank you, Dr. Kamath, for accepting our invitation and being here. I also welcome our Division Dean, Professor G.K. Anand Suresh, Dean of Mechanical Sciences Division. Welcome, Professor. And our own Department Chair, Professor Joseph Matthew, Chair of Aerospace Engineering. I now request Professor Joseph to accompany Professor Anand Suresh and Dr. Samir Kamath to the stage. Thank you. We also have two very special guests with us today, family of Professor Narasimha. Professor Narasimha's wife, Dr. Neelima Narasimha, is here. Thank you, ma'am, for coming. And their daughter, Professor Maitreyi Narasimha, is also here. Thank you. Thank you, Maitreyi. Your presence means a lot to us. There are several distinguished scientists and professors in the audience. You'll have to accept my apologies for not greeting you individually, and I'll get away by doing a collective welcome. Welcome to the event. Thank you very much for being here. So I'd like to now call upon Professor Joseph Matthew to share some of his thoughts on Professor Narasimha and also talk a little bit about our hypersonic wind tunnel facilities here. But before I do that, I'd just like to make a quick note that this is the center of attraction for today. So this is our 0.5 meter diameter enclosed free jet hypersonic wind tunnel facility, which can be operated in the Mach number range 6 to 10. Okay, now I'll hand it over to Joseph.
Good morning and welcome. Sri S. Somnath, Secretary, Department of Space and Chairman IISro. Dr. Samir Kamath, Secretary, Department of Defense, R&D, and Chairman, DRDO. Professor G.K. Anand Suresh, Dean of the Division of Mechanical Sciences. And Dr. Kota, who, while at ADA, designed, built, and delivered the LCA. I'll have something more to say afterwards. Dr. Pashelkar was expected, perhaps he's delayed. He's currently the director of NAL, where Professor Narasimha was director for about a decade. Dr. Shailesh Nayak, Director NIAS, where Professor Narasimha was the director for about 7 years. We had also invited someone from HAL. These are places where Professor Narasimha had a very substantial engagement. Of course, his work does not stop with this or with just this. There's a lot of other academic activities also. But I wanted to mention some of this before turning to other things. I do want to say a few things about the history of this facility. But I also wanted to use this occasion to have you all reflect on the origins of this facility. To that end, I've written down a few things. I've already missed out some stuff, but let's see. Okay. Professor Narasimha proposed a 0.2 meter diameter free jet tunnel as a pilot hypersonic wind tunnel. There were other plans in the country, but I want you to look, think back on those times. This is the 1970s, and this is an extremely specialized facility. Is the sound not clear? Okay. It's an extremely specialized facility. We had limited resources then. What is it that made this a need of the hour then? I want you to think about it. I remember the 70s as a time when India was in all kinds of troubles, on many fronts. And it's at that time that there was a plan for this facility. It started as an ARDB project, which was granted in 1976. Prof. Narasimha was the PI on the project. And it was, as I said, it was to be a pilot project. Now, while we need to attend to immediate needs, there is certainly a need to think about the future. What did he see the future as? I think he had an incredibly optimistic view of the future that India would have. And it is only if you have that kind of an optimism that you think about a facility like this. We might think that, okay, we'll do some things, and if we get somewhere, then we will think of a facility like this. I think, I'm not asking you to do anything, but I just want you to reflect on why it is important to think about the future and about the future that we want. It is not, vision is not just for a few people. It is for everyone. And it is for everyone to understand their role in bringing it to pass. Prof. Narasimha didn't merely have a vision. He chased it relentlessly. A person of that ability did not chase it just in one field. He chased it on many fronts. And we can see how many of these things have come to fruition now. So maybe we should think about what we can do as well. I want to talk about another vision that he had. In 1993, when we were both at NL, he was a director and I was not. I think that's the best way to say it. I heard him speak about civil aviation. He presented the case for civil aviation. In 1993, where were we in civil aviation? Most of what was available was Indian Airlines. And it's only when you do the hard analysis that you can form a basis for the future. And he said, civil aviation will grow, and we should actively participate in this. Civil aviation has exploded over this period. But what has exploded is the number of aircraft that we have imported to do this for us. It's been great for us as individuals. But his vision went beyond that. He said, we should build the aircraft. And this is where I think Dr. Kota, who has been pursuing that also relentlessly for all these years, and Dr. Pashalkar, who has also led the team on the aircraft. That is still a work in progress. He has been telling us several times on several occasions that we need to do this. But it hasn't been realized. I think we should work towards getting there. In my personal view, it is not just the aircraft. We can build the engine too. It was a good idea in 1993. There's much more to convince us that it's a good idea in 2023. So please think about this. One other thing I want to say about this, Professor Narasimha didn't just tell us that we should all be doing this. He also worked for it. He designed a new wing. So this is what someone who thinks that this will happen will do. He spent his time designing a new wing, right? So vision needs to be realized, and I think we do have to pursue relentlessly, even if we can, by his example, look around and see the state of affairs and not get discouraged. I don't think he was discouraged by what happened, what is going on around. He still pursued all this. And I thought on this occasion I should say something like this. Okay, now let me come to the tunnel. As I said, Professor Narasimha became the PI on an ARDP project to realize a free jet at Mach 8. This was to be an 8-inch or 0.2 diameter fist jet. The sanction was for about 40 lakhs then. The principle is quite straightforward. Even someone who does theory like me will tell you if you have a pressure ratio, high pressure, low pressure, and a certain geometry, you can get supersonic flow. What is required here is Mach 8 flow. So the upstream pressure was going to be 140 bar, 140 atmospheres. But there were tremendous engineering challenges to realize this. The project was sanctioned in '76. The tunnel was commissioned in 1985. There were certain kinds of equipment that were not available in India. The compressors used to generate that actually sit behind this wall from those days. There's new compressors here. That we could procure. Not we, they could procure. But fortuitously, in 1966, there was a company that was set up, Bharat Heavy Plates and Vessels, which could make the high-pressure vessels, the multi-layered high-pressure vessels. There were some issues related to the heater. So like I said, there are several engineering challenges, and these were overcome step by step. I don't want to get into the details. I heard about this from Professor Narasimha when Mr. Vasudevan retired. At that time, he recalled this and other issues related to the solutions for the heater and so on. Some of it was done by faculty in the department. Professor Mukunda and Professor Prabhu worked on part of the heater design. But a crucial development was when Mr. Vasudevan joined IISc finally in 1984. At the same time, Professor M.A. Ramaswamy, who's also here, he also joined this lab. And in '85, that was commissioned. Shortly afterwards, that was converted to, or a few years later, it was converted to a 0.3 meter tunnel. And that's the one that lies parallel to this on the other side. On that, there were 35,000 blowdowns, 18 projects for ARDB, 80 for DRDO, 6 for ISRO. About 5,000 blowdowns were used for thesis work by students for PhD and MTech work. Later, ARDB gave a further sanction, and then that's how this came up, the 0.5 meter. So actually, when you go from 0.3 to 0.5, it's not a linear scaling. So a lot of things have to be done appropriately for that. And it has been, this was commissioned in April 2014. It has been quite active. It is expected to provide excellent service for both DRDO and ISRO, and perhaps a lot more fundamental work will also get done here. We have many enthusiastic students, and they're working on problems for their PhD here in this very unique facility. So, I want to end by saying that this is a very small tribute to Professor Narasimha that we can do by naming this tunnel in his honor. We are well aware that adding his name brings a lot of honor to this lab and this facility. But we think that is useful. I'm very happy all of you have come to give it that legitimacy. We want students and visitors who come here to see that name and perhaps ask why, because in a little while there'll be people coming here who have not known of Professor Narasimha, and then they may reflect and they may think of a vision for themselves and decide to do something to bring it to pass.
Thank you, Professor Mathur, for those remarks. I personally think it helps to periodically recount these histories in detail. And this is a classic case of standing on the shoulders of giants. It is because of the work done by Professor Narasimha and colleagues in the 70s, 80s that now people of my generation are able to push forward and compete at the global scale. Thank you again for those remarks. I now invite our Division Dean, Professor Anand Suresh, to share his thoughts.
Shri Somnath, Dr. Kamath, and Professor Joseph, Matthew, and all the distinguished guests who are there, and good morning to you all. I envy all of you who had an opportunity to work closely with Professor Roddam Narasimha. I don't work on fluids, so I didn't have much interaction with him on research. But there is one person in this audience that I most envy, and that is daughter, Professor Maitreyi. And madam, I really envy you because I know Professor Matthew talked about there are two parts of the brain, people say. He covered one part of the brain, I've covered the other. Because Professor Narasimha was interested in fine research and also fine arts. And many things that he had done, of course we know his research, but other things he had done were equally remarkable. And I said, I don't work on fluids, but I can talk about one work of Professor Narasimha which was on solids. He had worked on nonlinear vibrations of strings. That was in 1968. I was only 1 year old at the time. And it was remarkable that that work, after 50 years, people are saying that's a correct equation for a nonlinear vibration of a string. And why should a person interested in fluid mechanics work on strings is something that I was not sure about. I was watching some of the videos and interviews of Professor Narasimha and read about what people have written about him. And I found that, and the family can confirm, he had actually learned Veena for 4 years, he said. And then afterwards, when he joined academics, and he said, art and science cannot go together, but actually he practiced both, I must say. It was looking at the string, whenever you give a twang on it, he said, it doesn't vibrate in one plane. It actually has a tubular things at resonance. There was a coupling between transverse vibration and axial displacement of the string. And that's what he corrected, that equation, and wrote a paper, 1968. And he got a reply from Professor Truesdell, the former professor of Caltech. And he had objected to a small thing about not attributing the material coordinates. We have material and field variables. That's what Professor Truesdell objected. And in the interview, Professor Narasimha says, if Professor Truesdell has to say only about that, that means that what I had written, rest of it is correct. And in fact, it was. So it was his fascination with Veena that made him probe into nonlinear vibrations of a string. And there are many occasions when he writes about fluid mechanics, he loves vortices, he would say, I remember reading an article in Resonance, the Academy's education journal, where it would say that Otex is fit for a Mysore silk saree border. He always saw the art in the things that he do. And he would give a talk on clouds. Clouds are something fascinated him, apart from monsoon as well. And I remember reading somewhere that as a boy, he used to look at the clouds. This photo shows looking down, but I think he probably looked at the clouds all the time. He was known as Akasharaya, because somebody, standing next to him as a boy, he was standing in a queue, we are looking at the clouds. So he was always fascinated by clouds. And of course, he did a lot of research, as we all know. When he gives a talk on clouds, he would quote poems from Kalidasa's Rutusamhara or Meghadutam, and deep quotes. These are not just quoting something. He would actually say that the poet knew something about the clouds. Any observant person, need not be a scientist or a researcher, would be able to capture. He would show a painting and say that art has captured this cumulus cloud properly. And it's not just the physics that he was well versed with, but also metaphysics. Some of you probably know that he translated Yoga Vasistha into English, and its title is Verses for the Brave. I'm sure all of you are brave to read them. And there was one shloka that I recently read it, and I could relate to. It's not just he wrote about it, he actually practiced it. That shloka goes like this. I hope I remember it now. Yukti yuktam upadeyam vachanam balakadapi anyat trinameva trajyam apyuktam padmajanmana. It translates to, if a rational argument is presented by a young boy, you should accept it. If something is not rational, even if it comes from somebody who is very learned, you can throw it out like a straw. And he practiced it, because I can tell you one anecdote. Once there was an undergraduate here in this institute. His name is Suhas Mahesh. He was in physics. And I came to know by looking at CV that he was interested in Sanskrit. Prof. Narasimha knew Sanskrit very well. And this boy, I would use the word boy, undergraduate, and he knew Sanskrit like I had not seen earlier. He knew so much about it. And I asked him, can you give a talk to all of us, just about Sanskrit? And just the email went to Prof. Narasimha, and he was an invitee, or not even invitee, he was just an attendee. And he came to that, to listen to undergraduate who talked about Sanskrit. There was another occasion, Professor Bhimanath has written a wonderful book called Nothing is Blue. I recommend it to all of you. He used to teach our undergraduates also, he's at RRI. And that's about Nalanda and lots of things of that time, when Nalanda was at the time of its decline. And to that also, just an email that goes to like a campus bulletin now to everyone, but he would come. Nobody invited him, he would come. And he extended the whole talk. That was undergraduate. So he actually, even if from a boy something rational comes, he would appreciate it. That yukti is something you always used to talk about. What is proof for Greeks? He used to say yukti is for ancient India. And not only that, this thing about he talks, and when he talks of cumulus clouds, there's another shloka that I would like to recall right now. This is by Shelley. The last 4 lines of that poem read as follows. I silently laugh at my own cenotaph. Out of the caverns of the rains, like a child from the womb, like a ghost from the tomb, I arise and unbuild it again. Unbuild it, not rebuild it. Arise and unbuild it. That's how he says clouds. This is actually Shelley wrote cloud talking about itself. And I look at this cenotaph now and say that we should not stop there. So that Professor Narasimha also would not silently laugh at this cenotaph. What we need to do is we have to read his works. And I also want to recall one thing that we had tried from the IISc Press to bring his collected works as 1 volume or 2 volumes. And he had, with a lot of persuasion, that was he. He always had something better to do than looking at his own works. But we persuaded him, Jayavant Tarakeri and others. We did that, and he somehow identified the papers that could go in his collected works. And we wanted him to write about those works, the 5 or 6, a paragraph about it, but that could never be his priority. He has identified the papers, some people have written. Now, what I would like is his spirit of inquiry should continue. We have already named a high-performance cluster after him. Now this wind tunnel, maybe we'll have a seminar hall or a building. All of those remain cenotaphs. what we need is the spirit of inquiry continuing. So I would urge our young colleagues and old colleagues, and myself included, I will be happy to help, to bring out that collected works. IISc Press has agreements with scientific publishing, World Scientific Publishing, and Cambridge University Press. One of them we can convince to bring that. People might say everything available on the internet, why do you need collected works? I myself did not know that Professor Narasimha had worked on strings, right? So there may be many other works that get buried in the literature. Even the best search engine might not be able to bring it to you. So I would like to see that collected works come about, so that his influence will stay for a long time. In fact, maybe we should encourage our students to read all his papers and find the relevance of those works today and how they've influenced the past work on fluid mechanics. And that will be an educational experience for all of us. His legacy will continue. Thank you.
Thank you, Professor Suresh, for those really wonderful remarks. I'm very happy that you brought out an entirely different facet of Professor Narasimha's life. Joseph talked about all his work in hardcore experimental aerodynamics and brought out the other side of him. So as many of you know, he was a multifaceted personality. He was an aerospace scientist. He was a hardcore engineer who actually designed aircrafts. He was a historian of Indic science. He was a philosopher, a scholar in Kannada and Sanskrit, and many more. So thank you again, Professor Suresh. So it's now time for us to formally dedicate this wind tunnel to Professor Narasimha and name it as the Roddam Narasimha Hypersonic Wind Tunnel. I request our chief guests, Sri Somnath and Dr. Samir Kamath, to unveil the ceremonial stone. Since Sri Somnath is not here, who is incidentally at the Satish Dhawan Space Center, Professor Narasimha's guru, Satish Dhawan, I request Dr. Samir Kamath to do the honors on behalf of Sri Somnath as well. We'll soon place this ceremonial stone at the main entrance of the building. I'd just like to read out what it says for the benefit of those sitting at the back. The half-a-meter diameter enclosed free-jet hypersonic wind tunnel housed in this building was dedicated to Professor Roddam Narasimha and formally named in his honor as Roddam Narasimha Hypersonic Wind Tunnel, jointly by Sri Somnath and Dr. Samir Kamath on 28th May 2023 in the presence of Professor Narasimha's family, friends, students, colleagues, and scientists from India's aerospace community. All right, now I'll invite Sri Somnath to address the audience. Sri Somnath.
Thank you. Am I audible? Just a check.
Yes, please go ahead. We can hear you.
Okay, okay. Oh, thank you so much. This is a great honor to me, an alumni of Indian Institute of Science, to had the opportunity and good luck to have the mentorship of a little bit of time of Professor Narasimha, to have the honor of dedicating one of the important facility, a research facility in his name. So thank you so much for allowing me to be part of it, to be joining along with Dr. Samir Kamath to unveil the plaque and also dedicate this name, his name to this facility. On the dais, Dr. Samir Kamath, Dr. Ananda Suresh, Dr. Joseph Matthew, the family of Professor Roddam Narasimha, Mrs. Narasimha, and his daughter, Maitreyi. My greetings to you all. And also the aerospace community represented here by many of you leading lights, which I don't want to name. I am seeing their face and really happy to see them assembled today. And let me express, I am really sorry that I am not able to join in person, though I agreed that I will be able to come. But then launches are fixed just like this. And I need to be here for a launch that is going to take place tomorrow at 10:42. The countdown of that was just happening today at 7:12 in the morning. So somehow I am not able to find a way to make it to IISc. So sorry for that. first of all, this, as Professor Joseph Matthew mentioned, it's really important to have the blessings and presence each of you to give the legitimacy for this function of dedicating a facility like this in the name of Professor Narasimha, because it means so much to this activity that you are undertaking in this department in Indian Institute of Science to name yet another facility in the name of Professor Narasimha. And his names are likely to come in many more places. I am very sure about it. But this is so special because the domain that he has contributed, especially in the domain of aerodynamics, experimental aerodynamics, analysis of space vehicles, and also the support that he gave to institutions like DRDO, NAL, ISRO is really, really significant. I only want to tell you that at this moment, I am not a right person to comment on his work or his contributions, but I had the fortune to see him supporting our organization's activity in a big manner, especially with ISRO. I think his working together was still his last. He has been a member of the Space Commission for many years and advised the top leadership of the organization on its programs, projects, approaches, etc. throughout his membership in the Space Commission. And later, after he left it also, he continued to mentor and support in most of those decisions that we used to take in programmatic way or technical aspect as well. In many reviews, I think his contribution is significant, especially whenever we face failures. Wherever we had issues in flight dynamics or aerodynamics, especially with respect to rockets, which we had enough in the early past, where we spent quite a bit of time to understand the aerodynamics of rockets. I think his ideas, his approaches, his very different way of thinking. I think we all witnessed as young boys sitting by the side of those big review fora. I think we all benefited by that. But the biggest blessing came to me when I was maybe few years back, not very early, maybe 15 years back or so. There was a mentorship session where Professor Narasimha was the mentor for 30 of us from ISRO. We were selected across the centers of ISRO. We were brought to a NIAS, and we were spending almost a week plus 10 days or so with him, listening to top people in this country on science, technology. And he was there with us throughout. And he was actually watching us, analyzing us, observing us, sitting there silently and looking at each of us to understand what the capability of each of us are really. And possibly he would have made his own assessment of each of them. And I know today that many of those people in that list of 30 people who were brought on that day became very well-known project directors, center directors, contributors significantly in the program of space, including me. I think that is his capability. And he handpicked people out of those group to give higher responsibility in the organizational structure. And really we benefited by his ability to find out the talent, as already been mentioned by Ananda Suresh, how to look at for those people who really make things happen. I think that is this capability. We all know about the hypersonic wind tunnel. I think the hypersonic wind tunnel is such a complex machinery. We had a fortune to build one in ISRO, 1 meter hypersonic wind tunnel, and we realized how complex it is. Much later that we built it, made it operational, it was really an engineering challenge of very high magnitude. And I can understand when you do it in an institution like IISc, not having that much of people or support system to do it, it would become a great challenge. And even the early development of 0.2 meter hypersonic tunnel I just mentioned about the type of challenges faced in realizing facilities of this magnitude. So it's really an engineering skill. The frugality of doing things in an institution like us could have been the challenge at that time. But today it is feeding into the creation of the type of talent pool in this country. Understanding high flow aerodynamics and then make sense out of it. Today we depend so much on computational solutions for these areas, but we still realize that the testing in this type of equipment, tunnels become so important. I still remember when we were designing rockets, maybe 10 years back or so, there were questions asked, when are we going to retire all these wind tunnels? Because our computational capability has become so good that we may not ever require any more testing facilities in low speed aerodynamics or even supersonics or in hypersonics. It may not be called for at all. These were some of the discussions that happened at that time. And many people were supporting that view because our computational capability has become so good. I think testing is not necessary. But to our surprise, I think we are realizing it today when we are working on problems like human spacecraft development and return from orbit to Earth at hypersonic speeds, or even scramjet testing where we have such a dynamical situations involved like cowl opening and very high rates which are involved in the rate of change of the flow, or even return of reusable launch vehicles like winged vehicles where aerothermodynamics is so important. Testing of this subscale models and correlating with the models becomes so important. And we were able to find out the type of differences that exist in testing versus theoretical models and the deficiency that still exists in terms of the computational capability we need to build over a period of time. And sure, we will come closer and closer over a period of time, but the testing becomes so important to understand and also to use the data appropriately. I think this also becomes important. It's not just the data that will be used, but how to put it to use. It's also very, very important. So testing is essential part of it. Even today, for most of our programs, we depend on external agency testing facility. We have a huge testing facility at NAL. In ISRO, we have subsonic testing, we have hypersonic testing, but we are dependent on many other world organizations to test our launch vehicles and various other missions from Russia, from Canada, from Romania. Even then, we are not able to meet most of our test requirements. It's such a huge demand. And we need to create facilities of this magnitude in our country. I think those actions which are being taken are really praiseworthy. So at this moment, let me thank once again for the opportunity given to me to remember us about Dr. Prof. Narasimha and also his contribution. I would like to also to say I had the fortune to give the Prof. Narasimha Memorial lecture at National Aerospace Laboratory on his on their annual lecture series, and it's really again another blessing today in being part of this dedication ceremony. Thank you so much, and very happy to meet you. And maybe as at this moment, let me also seek the blessing of the entire aerospace community for our success of our launch that's going to take place tomorrow as well, because it's so important for us. The GSLV is going to be launched. This time launch is happening on a rocket which failed last time. So after a failure, always the next launch is always has its own the element of suspense and risk. So we are enjoying that at this moment. So thank you so much for this opportunity, and wish all the very best to aerospace engineering department and also the mechanical engineering division and all those who have worked to make this event happen. Thank you so much.
Thank you very much, Sri Somnath. I think it's safe to say it's not just the aerospace community, but the entire nation that wishes you well for tomorrow's launch. Thank you again for those really wonderful remarks, recollecting your own personal association with Professor Narasimha, bringing out some of his top-notch leadership qualities. You also talked about the exciting things that are going on right now, scramjets, human space flight. So I'd like to believe that somewhere out there in the cosmos, Professor Narasimha is watching and following all these developments with great excitement. Thank you again. Now I'd like to call upon Dr. Samir Kamath to address the audience.
Thank you, Professor Subramaniam. Sri Somnath, Professor Matthew, Professor Anand Suresh, Professor Narasimha's family, all the dignitaries who are present here, and faculty of Aerospace Engineering Department in IISc. So I am indeed privileged and honored to be here. I think it's time we start paying tribute to our scientists and intellectuals who have played a role in shaping science and technology in the country. I think the country does not do enough to recognize the scientific talent which this country has grown. Though I would say Professor Narasimha was more than just a scientist. He was a true intellectual, I think, whose contributions in several fields are noteworthy. I am a metallurgical engineer by training, so I have not had the personal experience of working with him or going through his work in detail.
Right.
But I can say that his contributions have helped DRDO in almost all the aeronautical programs as well as several missile programs that we have. We would not have been able to achieve what we have without his seminal contributions. I think in addition to his scientific work, his leadership in turning NAL into a world-class laboratory is also very noteworthy. We need more scientists, more leaders like him to emerge. Our Prime Minister has set us a vision to become a developed country by 2047. We can become a developed country only if we become leaders in technology. And technology leadership can only happen if we remember our past leaders, use their memory, nurture new talent, and take risks. Being in government, we are always reminded by finance that you have to follow GFRs. We have very low tolerance to failures. We are always told that there will be a CAG audit if you take any risks. But if we don't take risks, we will always be followers. I think it's not wrong to fail. In fact, you learn more from your failures than your successes. I think it's wrong not to take risks, take up challenging problems, which we all avoid in the government sector as much as possible, as I said, to avoid CAG coming after you later. But I think this mindset has to change. And I'm happy to say that I see some seeds of change in Delhi. So my best wishes to the facility which you have set up. It has been in existence for 4 years. I think it will contribute significantly to all the aerospace work which is going on. And somebody mentioned that we should make aero engines. I think that should become a reality soon. At least manufacture of engines should start soon, and hopefully a co-development of the next generation engine should also start soon in the country. So I think it's an exciting time to be an aerospace scientist in the country. DRDO also is working on hypersonic glide as well as cruise vehicles. ISRO also has programs. So there are several programs on the anvil, and facilities such as this, as Somnath described, are going to play a key role, even though computational fluid dynamics has advanced. So my best wishes to everyone who's gathered here, and my tributes to Professor Narasimha for all the contributions that he has made. Thank you.
Thank you, Dr. Kamath, for those very thoughtful remarks. I remember Professor Narasimha telling me and some of the other students many years ago, many times, that you cannot make serious technological progress in aerospace without taking calculated risks. Thank you for bringing that up again. So we have a little bit of a surprise here, which was not part of the planned program. So one of the, Professor Narasimha was involved in various national programs in aeronautics and space. And one of the projects that was his dream, for which he was a brainchild, was the LCA. So 2 years ago, there was this very nice book that was brought on the history of LCA, Radiance in the Indian Skies, the Tejas Saga, authored by Air Marshal Philip Rajkumar, who's with us today, and with journalist B.R. Srikanth. So they'd like to present autographed copies of their books to the chief guest. So now I call upon Air Marshal Rajkumar and Srikanth to please come up and present the book. So that almost brings us to the end of the formal part of the program. I'd like to take this opportunity to thank our chief guests, Sri Somnath and Dr. Samir Kamath. Thank you again very much for being here with us. Means a lot to us. And also to Professor Anand Suresh, our Division Dean, and Professor Joseph Matthew, our department chair. So we have a little souvenir pack for our chief guest. So now I request Professor Anand Suresh to please hand it over to Dr. Kamath. And I request Professor Joseph Matthew to hand over some souvenirs to our Dean, Professor Anand Suresh. And maybe I will just hand it over to my department chair, Professor Joseph Matthew. Thank you all to all of you for being here. Several distinguished members of the aerospace community, former colleagues of Professor Narasimha, former students, present students of the institute, and everyone. This was a wonderful event, something that I for sure will remember for a long, long time. So thank you again. We have a little reception at the back for a little high tea. So you can join us there. And on your way to the high tea, we also have some souvenirs from the event for all the guests. So please pick up your souvenir and join us for the reception. And at the back, we have some research posters for those of you who are curious to know what we are doing right now in this facility. And the students will be there if you have any questions to satisfy your curiosity. Thank you all once again.